Hey, Grandpa, can I get a towel?
What is happening? Holy shit.
Tree across the street hit my neighbor's house, smashed the roof of her garage. It was like,
I'm amazed right now. I'm really amazed right now because these trees have been here for a very long time.
Emergency crews. Now, as you can see, fire and rescue crews are here, along with Red Cross and Animal Control, supporting the people who are now displaced by all of this damage.
What's up, baby? We out here live and direct. Testing, 1, 2, 3. We good? Mic check.
Hey, mic check 1, 2, 1, 2.
yeah, talk to him.
Mic check 1, 2, 1, 2.
Okay.
It's a lovely day.
Okay, so basically, I forgot to hit streaming. So basically, there was severe weather in Las Vegas today. So this is where this incident happened. So all these trees came down basically. This tree came down. This tree came down. This tree came down. I mean, even this tree came down. I mean, there was lots of tree damage today. So all of these trees came down. This tree came down. This tree came down. So this tree came down. This tree came down. This, and this tree came down. Basically, you had a microburst that went through Las Vegas, through this neighborhood of Las Vegas. It was like right in the downtown area, right near downtown. You had a microburst that went through, basically. I mean, these trees are very top heavy, so it could be easy for strong winds to knock them over. I don't think 50-mile-an-hour winds would knock these trees down. They said, no, I think it would take 70, 80-mile-an-hour winds to knock these trees down, especially in an area where the trees are really well rooted. These look like very healthy trees. The winds must have been really strong for that kind of damage. Most likely it was a microburst. It's the only logical conclusion.
When I was growing up, I would make my own little homemade music videos. My favorite thing in the world was to edit them. It was so satisfying to me. This lighting is actually pretty amazing, and this kind of close-up. I really get inspiration from everything.
So people are rattled as multiple trees crash into their homes, falling on their cars. Our Katie Munch is live there with a look at the damage now.
Yeah, we're in a neighborhood just off East Sahara where 55-mile-per-hour winds caused some damage, Marie. Take a look. It starts just right over here with this tree up.
This tree, they're showing. If you look closely, it almost looks like it's actually going through that house. It almost looks like it literally like went through. Like,
with this tree uprooted, leaning on top of this house. And then here is a second one.
Okay, so those two trees are, these two trees. This one got uprooted. This one is the one leaning on the house. And yeah, it literally looks like it literally went through. I don't know how that is possible. But yeah, maybe it's because of the, there we go. So it basically fell here in the corner. Now there is a reason for that. Okay, so now, yeah. So now it's
completely uprooted at the top of this house.
So basically there's a corner right here. So basically, even though you can't really see it because it's dark,
and then here
there's actually, you can almost see that little corner, see? Right there.
is a second one complete. Here is the top of this house.
There's
And
right, hold on.
then here
So, but yeah, so.
is a second one completely uprooted, leaning on top of this house.
To
And
an untrained eye, this would look like the house is going, the trees actually going through the siding. But it's actually an optical illusion. You see there's a little porch here. And you see the little porch here, right there, and then the windows here. So it's this area. So all these trees came down. This tree came down, leaning on the house. This tree was knocked down this way. And both of these trees are leaning as well. Let's watch the rest of the video.
And then here is a second one completely uprooted out of the ground, but watch, it lands on top of this vehicle, shattering the rear windshield.
I knew this was going to happen. I was talking about how Las Vegas was going to get hit again with storms. I mean, the monsoon is really active. And what did the Storm Prediction Center say for Las Vegas? Let's see. And of course, they're not putting Las Vegas in a marginal. I would put a marginal risk for microbursts. I actually would. I actually would put the Las Vegas area in a small marginal risk. I mean, I'm surprised they didn't put Las Vegas in the marginal with all these damaging winds going through. Knowing how and look, even Los Angeles is in a threat of thunderstorms. Look at that. Even Los Angeles, thunderstorms. Wow. This time the monsoon is going all the way to the coast. Well, this is today. Yeah, but it looks like Los Angeles might actually get some rain today. Look at that. Monsoonal rains all the way to the coast. You don't see that every day. And yeah, I'm looking at radar, and there's actually some light rain approaching San Bernardino from the northeast. There's still flash flooding. Wow. There's actually a trail of severe thunderstorms, of heavy rain and thunderstorms approaching the Los Angeles area. Well, south of Los Angeles. This is crazy. Look at that. Thunderstorms. Oh. This is crazy. Ow! Oh man, my neck. My neck's killing me. All right, yeah, let's look at the rest of the video.
Barely missing this car over here, and then there's two more completely uprooted trees landed on top of this other building, and right over here across the street there's another one completely uprooted on top of cars in someone's home. And it does not end here. On the next street it seems like there are dozens more of uprooted large trees just like this one on top of people's houses and vehicles. We talked to some of the neighbors here who were inside of the home when the winds hit. Listen to what they had to say.
The street tonight looks like it's just pandemonium. It blew down like 5 trees all within the neighborhood here off Karen. I haven't seen wind this hard in 20 years when it blew over the Hilton sign.
Inside, I see the trees fall off here, hit my neighbor's truck. The tree across the street hit my neighbor's house, smashed the roof of her garage. And it's like, there's trees falling down everywhere around here.
I'm amazed right now. I'm really amazed right now because these trees have been here for a very long time.
Emergency crews. Now, as you can see, fire and rescue crews are here along with Red Cross and animal control. Completely. Per hour winds caused some damage, Marie. Take a look. It starts just right over here.
These winds were probably 70, 80 miles an hour.
with this tree uprooted, leaning on top of this house. And then here is a second one completely uprooted out of the ground. But watch, it lands on top of this vehicle, shattering the rear windshield, barely missing this car over here. And then there's two more completely uprooted trees landed on top of this other building. And right over here across the street, there's another one completely uprooted on top of cars in someone's home. And it does not end here. On the next street, it seems like there are dozens more of uprooted large trees just like this one.
Yep, see these trees on the side right here?
More of
Those trees here are the ones here. This tree. I mean, yeah, this tree's leading over, but yeah, this is crazy. This is just insane. Yeah. Oh, look at that. 2 people are watching my stream. Yeah, casinos got flooded out yesterday, and today trees are being knocked down. I mean, the weather is just crazy today in Las Vegas. I mean, this is the second day of crazy weather in Las Vegas. Jesus Christ.
Uprooted large trees just like this one on top of people's houses and vehicles. We talked to some of the neighbors here who were inside of the home when the winds hit. Listen to what they had to say.
Serena night looks like it's just pandemonium. It blew down like 5 trees all within the neighborhood here off Karen. I haven't seen wind this hard in 20 years when it blew over the Hilton sign.
Outside, I see the trees fall off here, hit my neighbor's truck. Tree across the street hit my neighbor's house, smashed the roof of her garage. And it's like, there's trees falling down everywhere around here.
I'm amazed right now. I'm really amazed right now because these trees have been here for a very long time.
Emergency crews. Now, as you can see, fire and rescue crews are here along with Red Cross and animal control supporting the people who are now displaced by all of this damage.
What's up, baby? We out here live and direct. Testing, 1, 2, 3. We good? Mic check.
Hey, mic check 1 2 1 2.
Yeah, talk to him.
Mic check 1 2 1 2.
Okay.
It's a lovely day in Vegas. What you gonna do?
Yeah.
Hey, you know I gotta get a handstand. I'm mic'd up. Check this.
Okay, oops. Delete. An area of low pressure is currently spinning through eastern California along the Arizona border in a monsoonal area. Looks really interesting on radar. Bingo. Video. There we go. Good. The swirl is clearly visible. There we go. Just spinning. Spinning. That's spinning. Tweet. That was so ridiculous the way. Yeah, so basically an area of low pressure is spinning through the eastern California-Arizona border. Okay, now let's focus on the National Weather Service. Flash flood warnings are still in effect, actually. Oh, look. Flash flood watch. A flood watch is in effect for areas just east of Los Angeles. Look at that. I think that's a flood advisory. Yeah, there's still flood warnings for rivers. This is for rivers, actually. Let's see for what river. Impact at 31 feet. Major flooding occurs. Oof. Flood stage is 21 feet. It's horrible. The river will rise to 30.8 feet just after midnight tonight. It will then flow below flood stage Sunday, morning to 14.4 feet Tuesday morning. To 14.8 feet early Tuesday afternoon. It will then fall again and remain below flood stage. 30.8. This is historic flooding in Jackson, Kentucky. This is horrible. Thankfully, that area didn't flood. Almost did. 100% humidity, dew point 67. Okay, so here are the monsoonal lows. You can actually see the trough. There's currently storms heading southwest towards the California coast. I don't know if they're going to make it, though. They might. They may not, but odds are they will probably mostly fall apart over the Los Angeles mountains. They'll probably rain out over the mountains tonight. Yeah, so I have work tomorrow, so I have to be going to bed in the next like 30 minutes. So by 4 a.m. I need to be at work because I have to get up like at 11. So let's look at the models again, the computer models. Right. I'm going to look at the NAMNES right now. I'm going to look actually at the GFS model right now. Let's look at North America. So these are the Pacific storms. Right now the Madden-Julian oscillation looks to be in its positive phase. So that's why you're having these storms. Oh, that is not good. Because I was looking at last night's run and it was showing a completely different picture. Actually, it was, I think, the 28th, actually. Yeah, it was showing a completely different picture. I mean, look what it was showing. Look at all this cold weather over the Arctic, and now it's just showing a major warming. You do not want this to happen. This is really bad. This is really, really bad for Arctic ice. Even this is not good because this will just, you see how you're having an area of low pressure? That will absolutely disrupt Arctic ice. Even though it's cold, it will still. I really hope that doesn't materialize. And this is not good. See, even though it's above, but you see how the angle at which it's falling? Okay, let's You see how the blue, right now we're falling at a much more rapid pace. We are not going to be here. We're going to be somewhere in this area here. I'm thinking maybe not as low as 2020, but I'm definitely thinking it's going to be, between 2020, I think it's going to be between 2018 and 2019, so somewhere in this range here. It'll probably fall like this, and then it'll probably recover. This recovery here, this recovery here happened because you had a cold, an area of low pressure, like basically a cold pool that went over the Arctic. If that happens, if we can get a cold area to form, if we can get an area of colder weather over the Arctic, that'll be really good. Especially if this happens. This is what I really hope happens. Like what the GFS was showing earlier, like the run it was showing here, this is actually would be the best case scenario. This is the best case. What it's showing here is the worst case. This is the worst case scenario. All this warm air coming off Siberia. It's literally the worst case scenario. And it's saying this will happen in around August 5th or sometime in the middle of August. This is not normal, actually. This is literally the worst case scenario. It could happen, but because the thing is, the earlier model was actually showing a very dominantly cold pattern developing. See? Crossing higher northern latitude, showing a very strong cold pattern, but now, around August 13th, but now it's showing not so much. Look at that. This is really bad. I mean, it could just be like a little glitch, but if this materializes, if this model materializes, this will be catastrophic for Arctic sea ice. What we need is a dominantly cold pattern. So let's go back to National Snow Ice Data Center. Let's look at the Antarctic, because, well, before I go to the Antarctic, let's look at the Antarctic Oscillation. Let's look at teleconnections. This is not good. You see how it's going down and it's going up? This is really bad for Antarctic sea ice extent. See how it dropped here right around July 23rd? This is why. See how it's going down? You want it to be positive. Like, you want it to remain in the, like, continuously positive. You see, it's up, down, up, down. These swings means that you're gonna have a lot of storms. When you continuously when we were continuously positive, and it was like this, just like wavy, it was almost like it was very stable in the positive range. This is what was actually happening. We were around 2000, this was 2017. Sorry, this is Antarctic, sorry. 2016 it was actually. My bad, 2015. Yeah, this is actually what was going on. This is back in 2014. The PNA was, the AAO was positive throughout without going negative. And if it was doing it really gradually. It wasn't doing it suddenly. And look where we were. We were all way above. Like, we were having record sea ice extent. And people say, look at that, global warming is a hoax. See? But then, just a few years later, boop, 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 look how quickly it changed. Look how quickly it changed. We can go from record highs to record lows all at once. Show all years. Yeah. And look where we are. You want to see? Oh. Yeah. Not good. Bad. Really bad. Even this year, like, sea ice extent is well below normal. That's bad news for glaciers because that means more warm weather can seep into the Antarctic area and melt the glaciers. And Antarctic glaciers are more important than Greenland glaciers because almost all of the sea ice, like 80% of the world's sea ice concentration is in Antarctica. I mean, glacial concentration is in Antarctica. If all the glaciers melt, sea levels will go up by at least 100 feet. That's how serious the climate change situation is. Basically, this is in part because of the collapse of the North Atlantic current. It's already collapsing. And it's basically flooding the Southern Ocean with warm water. Hurricane Frank. Georgette. Let's look at ocean temperatures here. They used to always be in the low to mid 70s this time of year. Low to mid. This is more or less normal for this time of year. Actually, it's good. Water temperature 78, 78, 78. And this is basically off of New Jersey. That is a little warm this time of year. See how it suddenly fluctuated? That's because of winds and yeah. This is by Block Island. Water temperatures here are very warm. This is off of southern New Jersey, basically. Oh yeah, same place. 78 degrees. This is off of the Delmarva, basically. Water temperature 73. That's, looks like the cold current is still there. This is off of Virginia. Oh, that's good. That's actually, this is Virginia Beach, 80, 81. Not too bad. That's more or less normal. This is near Bermuda. Near Bermuda, but not in Bermuda. Bermuda is still quite a bit away. Bermuda is actually right. Yeah, there's Bermuda. Bermuda Rise. That's the Bermuda Hot Spot. Bodwich Seamount. Bowditch Seamount, actually. That's part of the Bermuda Hot Spot. Southeast Bermuda, which means Then where is the volcano that would form the Bermuda hotspot? I don't see any evidence. Could this be it? George Seamount. Maybe it's George Seamount? Mark 28 on the map. And it's right near the Canary Islands, or the Azores. That's the Azorean hotspot. Of course, that's the Valles caldera. No, this is not concerned. Okay, I'm just trying to see. Okay, so let's look here. So that's the Azores hotspot. That's Lake Iceland hotspot. That's the Eiffel hotspot. Yellowstone, Hawaii. That is the Canary hotspot. Well, not the that's the Azorean. Sorry, the Cabo Verde hotspot. This is the Seychelles hotspot, the same one that actually caused in combination with the asteroid impact, caused the Draken flood basalts. There's some reason to believe that the Siberian flood basalts were caused by this eruption, the Icelandic hotspot, but in my opinion, the Icelandic hotspot actually, they said tracked across Greenland. So it could have been like, because of how the crust moves and how it's here. Yeah, Siberia was once over here and then it moved this way. Okay, in like 10 minutes I have to go to bed. So before I go, let's see how many people are watching. So I have two concurrent viewers, means at the same time. Concurrent means right now. Alright, but yeah, it's showing only one. I don't know. It could be just a system error or something. So right now we're looking at hotspots. So this hotspot is the New England hotspot that came from here. But now that the plates are spreading apart, how did it cross over? Is the question. Is it possible that actually this hotspot actually is hotspot number 1? Or is it hotspot number 2? Or 28? Is it this one or this one? This is the Canary hotspot. This is the Azores hotspot, and this is the New England hotspot. But the Bermuda Triangle isn't really here, I guess, because it's extinct. This is the Eiffel hotspot. This is the hotspot that's responsible for the Eiffel volcanism in southwest Germany, including the Lacher Sea caldera. There's actually a lot of interplate volcanism because of hotspots. Actually, Lake Pacto, the Pacto volcano, Mount Becdu, is even though it's considered intraplate volcanism, it's actually related to subduction. This volcano here, Mount Becdu, is actually related to subduction. Basically, you had slab rollback in the last several million years, so this plate was subducting very shallow in a very shallow angle, but then it suddenly steepened. So basically what happened is you still have a lot of water deep under in the crust in this region. So because there's some melting and quakes that are going on deep down, you have magmas that are melting and then migrating towards the surface to form Pactu Mountain here. But it's much further west. So that interplate volcanism is related not here, but actually further west in this area here. It migrates to the surface, forms your volcanoes. Formed one volcano here. There's actually a video about it that I'm going to watch. Actually watched a video about Changdao or Mount Pactu. This is the video I'm currently watching. This is the one.
It appeared to be a large barrier.
The large barrier is actually subduction. This is
Of unusually cold material. This puzzled.
I need to find the best way to learn math and science.
It's brilliant.
Whoa.
Here's a new way to learn math, science, and computer science that's fun and interactive. On Brilliant, you'll learn by seeing concepts visually and interacting with them, not just by watching videos. Check out courses.
The geological community. Once again, there was a form of intraplate volcanism that couldn't be explained. That wasn't a typical hotspot like previously thought. One of the largest volcanoes on Earth suddenly didn't seem to fit into any existing category. It was a completely new kind of volcano.
Not hotspot, not subduction, and not because of rifting. But here it is. It is actually related to subduction. He'll explain.
To understand what's going on here, we first have to understand this zone. Curiously, the cold anomaly observed here sits right inside the so-called mantle transition zone. This is the known transition zone between the lower and upper mantle. Here, the pressure is great enough that it changes the internal arrangement of the atoms by forcing the rock into a much denser, more compact crystalline structure. This results in a sudden, quite significant jump in viscosity in the zone. Because of this, the mantle transition zone acts as a sort of barrier in the mantle, which at least partially separates the processes in the upper and lower mantle from one another. Geologists quickly realized that the distinct anomaly of cold material in this zone can only be a piece of ancient crust. Expanding the image further to the east quickly reveals which plate it is. It appears that the Pacific plate, after subducting into the mantle, bends horizontally and becomes stagnant in the mantle transition zone right below Mount Pektu. This wasn't even that surprising. Ever since we began to understand more about the interior of our planet and its layers, it has been speculated that slabs after their subduction would become stagnant here. In fact, there was a fierce debate going on in the geological community, with one side arguing that the convection processes in the upper and lower mantle are separated from one another and that slabs after their subduction become stagnant in the boundary layer, while the other side argued for whole mantle convection and subducting slabs sinking all the way to the bottom of the mantle, forming a graveyard of slabs on top of Earth's core. But before you think clearly the first group had it right, here's an image of the subduction zone just a few hundred kilometers to the south. Here, you can clearly see the Pacific slab penetrating the mantle transition zone and sinking into the lower mantle. Likewise, global seismic tomography models have revealed an entire catalog of roughly 100 old slabs that have penetrated deep into the mantle. So clearly it's not as simple as picking one model over the other. That aside, there was also the question how a stagnant slab could even produce volcanism so far away from the subduction zone. Earthquakes provided an important clue. Most earthquakes on Earth occur, just like volcanoes, near plate boundaries, where the crust is bent and deformed by the collision of the plates. But seismographs in Asia also frequently pick up strong earthquakes deep below Mount Chengbai, 600 kilometers or 380 miles below the surface. Remember this chart, it'll be important later. Here, our story takes a bit of a turn because at the start of the 20th century, earthquakes became the center of discussion for a different reason. In 2002, the newly established Tianshi Volcano Observatory started to pick up a worrying increase in seismic activity 5 kilometers or 3 miles below the mountain. Over the next year, the number of earthquakes increased from an average of 10 per month to over 100. In some months, even over 200, signaling that an outbreak might be imminent. If we look at Mount Chengbai's eruptive history, we can see that it can be broadly divided into 3 evolutionary stages. The volcanic activity started around 20 to 30 million years ago as part of the large-scale intraplate volcanism that took place in Northeast Asia since the late Jurassic period. Around 2.5 million years ago, partial melting in the mantle below the volcano increased significantly and resulted in the eruption of extensive amounts of basaltic lavas, which even today cover an area of around 10,000 square kilometers or 4,000 square miles, with an enormous shield-like plateau, the largest in the region. Due to the enormous weight of this plateau, the rise of the magma below was eventually slowed down, so much that it began to collect in a shallower magma chamber before erupting to the surface. This was actually very important, as the extra time changed the chemical composition of the melt due to contamination from the crust and the deposition or removal of certain minerals in the magma. As a result, the lava that erupted onto the surface became a lot more viscous, which led to the formation of a volcanic cone on top of the basalt plateau. This second phase lasted from around 1 million to 4,000 years ago, and by the end of it, had produced a cone roughly 4 kilometers or 13,000 feet high. The last stage, the explosive stage, then resulted in the almost complete destruction of this cone, which brings us back to the millennium's eruption of 946. This enormous eruption blew off the entire top half of the volcano, creating the caldera that we see today. If you imagine the amount of material that must have existed between the 2-kilometer high surface of Heaven's surface. This was actually very important as the half of the volcano.
It didn't actually blow itself apart. After the eruption ended, the magma chamber was so drained that the volcano actually collapsed back in on itself after it erupted from the peak. So basically it was like it just collapsed. So it was an explosion, you drained all the material, there was nothing to hold up the mountain, and just collapsed back in on itself. Yeah, so just, yep, that's how explosive volcanoes work.
Volcano, creating the caldera that we see today. If you imagine the amount of material that must have existed between the 2-kilometer-high surface of Heaven Lake that partially fills the caldera today and the once 4-kilometer-high summit of the volcanic cone, it's not difficult to see that the Millennium eruption must have been one of the most catastrophic eruptions in human history. It produced a plume of smoke and ash that shot an estimated 25 kilometers or 15 miles into the stratosphere and ultimately covered more than 350,000 square kilometers between.
Yet it didn't produce any ash over the Korean peninsula. Everyone heard the explosion in Korea, but very little ash actually fell in Korea. I don't think it was just here. I would be like, usually an eruption so big it would even go like this, not.
Between northern Korea and the Kuril Trench in 5 to 10 centimeters or 2 to 4 inches of ash. That's an area larger than the entire Korean peninsula. The total amount of ash dispersed by the eruption would have been enough to bury the whole of New York City under almost 150 meters or 500 feet of ash.
Watch this. I can show you how to get the sweetest deals online when you shop from major retailers like Amazon and Target. You can drop.
Additionally, pyroclastic flows, avalanches of superheated gas and debris, filled valleys and canyons as far as 50 kilometers or 30 miles in every direction,